Chapter 16, Oxidation and Reduction. So we've talked about oxidation and reduction before. Let's review a little bit. Actually, this part isn't review. This is what we learned before. Oxidation is loss of electrons. Reduction is gain of electrons. Another way, and I think what was the original definition of oxidation is the gaining of oxygen atoms. So a compound reacts and it incorporates oxygen into its formula. Examples of slow oxidation would be rust. Rust is the reaction between iron and oxygen. And so it's the oxidation of iron. And one reaction for that is this: iron reacts with oxygen to form iron oxide, which we call rust. That is a slow process. Some of us with old cars wish it was a slower process, but it is pretty slow. Rapid oxidation would be those combustion reactions. So methane is the main compound in natural gas. It burns in the presence of oxygen, giving us carbon dioxide and water. In both of these examples now, the product has oxygen in it that wasn't there before. So iron now becomes a compound with oxygen. The methane loses its hydrogen and gains oxygen. So oxidation is gaining oxygen. Well, if that's our definition of oxidation, then reduction is the loss of oxygen. It's the opposite. Reduction is the opposite of oxidation. But redox reactions do not always involve oxygen. Here are a couple of examples. Here we have lithium reacting with oxygen. Okay, so that one does involve oxygen. But what about lithium reacting with chlorine? This forms lithium chloride. This is also an oxidation reaction. And so the definition of oxidation as being gaining of oxygen doesn't work for everything. It works great in organic chemistry, but it doesn't work well in inorganic chemistry. Let's look at what's going on here. Here we have lithium atoms, right? Lithium atoms with no charge. And what do we have over here? Are these still lithium atoms? Or are they lithium ions? They would be ions because this is an ionic compound, lithium and oxygen. Here we have lithium plus ions combined with oxygen 2 minus ions. So how did lithium go from being an atom to an ion? It lost an electron, right? So to go from lithium, the atom, to lithium, the ion, it loses an electron. In this reaction, the same thing is happening to lithium. We're going from lithium atoms to lithium ions. Here, the counter ion is chlorine instead of oxygen. But the lithium has still lost an electron. So a more encompassing definition of oxidation is the loss of electrons. So here, lithium has lost electrons. Here, lithium has lost electrons. It has also gained oxygen, and so it fits that definition as well. Oxidation is the loss of electrons. Reduction is the gain of electrons. These must occur together. If one loses electrons, another one has to gain electrons. There's no electron bank, there's no electron homeless shelter where you can drop off unwanted electrons. They have to go from one substance to another. So these always are paired. So what's happening here, lithium is being oxidized, so the chlorine is being reduced. Here we have a chlorine molecule with no charge, and here we have chlorine ions that have a -1 charge. They become an ion by gaining an electron. So that was the reduction. If we look at the combination of hydrogen and oxygen to form water, hydrogen is being oxidized. So the hydrogen is gaining oxygen. The oxygen is must be being reduced. So as if keeping track of oxidation and reduction wasn't confusing enough. We have to throw in another thing, the agents. So the hydrogen is oxidized, so it is the reducing agent. Okay, so let's think about Hollywood. You have the movie stars and you have their agents. Who stars in the movie? Who does the acting? The movie star. Does the agent do the acting or star in the movie? No. Does the agent get jobs for the movie star? Yeah. He acts for the movie star. So here, the hydrogen gets oxidized. It's the reducing agent because it causes the other substance to become reduced. Oxygen in this equation is being reduced, so it's the oxidizing agent. The oxidizing agent causes the oxidation of something else. So I understand that's confusing. Sorry. Yes?
So essentially, whichever one gives the electrons away is going to be the reducing agent.
The one that gives the electrons away is the reducing agent. Yes. It gives the electrons to the thing that's being reduced. Reduction is gaining electrons. And the way I keep them straight is I think through it. Every time I have to give an answer about this, like oxidation is loss of electrons, reduction is gain. Okay, and then the reducing agent causes the other one to be oxidized. I don't have any simpler way. Sometimes a slightly longer method that always gives you the right answer is better than trying to make up shortcuts. Any other questions? Okay, so this is a summary. We talked about this mnemonic earlier, oil rig. Oxidation is loss of electrons, reduction is gain of electrons. It's a great way to keep those two straight. And then the oxidizing agent causes the other thing to be oxidized. So it's not oxidized, it's the thing that's being reduced. The reducing agent is the substance that's being oxidized because it's causing something else to be reduced. The movie agent doesn't participate in the movies. He causes someone else to get into the movies. So let's do a couple of examples. In each of these, identify the substance that's being oxidized and the substance that's being reduced. Okay, we're going to leave the agents out of this for now. So let's look at this first one. Here we have potassium and chlorine reacting to form potassium chloride. What we're looking for is what's losing electrons, what's gaining electrons. And so we look at this and we recognize that's an ionic compound. Let's look at what the ions are. Well, we've got potassium, which is a positive ion, and chlorine is a negative ion. Over here, we have potassium, the element, no charge. We have chlorine, the element, no charge. So we've got potassium with a 0 charge. We don't usually write it like that. We've got chlorines with a 0 charge. Which one is, let's see, oxidation is loss of electrons. Which one is losing electrons? Potassium. Remember, electrons are negative. If you lose a negative, you become more positive. So potassium is being oxidized. Which one's being reduced? The chlorine. So the Cl2 is reduced. In a question like this, the answers always come from the reactants. Which one's being oxidized, which one's being reduced. And when we only have two, one's being oxidized and the other's being reduced. So let's look at B. Here we have aluminum reacting with tin ions to form aluminum ions and tin. So of these two here, aluminum or Sn2+, which one is losing electrons? The aluminum. The aluminum is going from a 0 charge to a +3 charge. It does that by losing 3 electrons. So the aluminum is being oxidized. We'll call him Ox. The tin ion is being reduced. Reduction is gain of electrons. To go from a +2 charge to a 0 charge requires that you gain 2 electrons. So we'll call that guy red. Any questions? Letter C, carbon plus oxygen to form CO2. Looking at charges of ions doesn't help here, does it? What definition of oxidation can we fall back on? Oxidation is the loss of electrons, but we can't really, nobody seems to be losing electrons. Gaining oxygen, right? So who's gaining oxygen, carbon or oxygen? Well, oxygen can't gain oxygen. Carbon's gaining oxygen. So the carbon is being oxidized. Something has to be reduced. There's only one other thing there. It's got to be the oxygen. Any questions? Same equations here. The question's different. Identify the oxidizing agent and the reducing agent in each reaction. What does the oxidizing agent do? It's the thing that gets reduced. It causes something else to be oxidized. So there's different ways to approach a problem like this. I prefer to do what we already did. So let's just go back to that and answer this new question. Because we already figured these out. The potassium is oxidized, the chlorine is reduced. So which one is the oxidizing agent? The chlorine. Because the chlorine causes the potassium to be oxidized. So here, I'll do these in blue. This is the answers to the question on the next slide. The chlorine is reduced. It's the oxidizing agent. And then the potassium must be the reducing agent because it causes something else to be reduced. So this is the reducing agent. Any questions? So in letter B, which one is the oxidizing agent? It's the tin ion. So I'm going to call that the OA, the oxidizing agent. And which one's the reducing agent? The aluminum. So the aluminum is the reducing agent. How about in letter C, carbon and oxygen, which is the oxidizing agent? The oxygen. And which is the reducing agent? The carbon. Yeah, I forgot what letter I was making. Reducing agent. Any questions? That's a sort of a question that could show up on an exam. This chapter is not on exam 4, but there are questions from this chapter on the final exam.